Hi. How are you all doing? I'm going to just take a sip of this water, if you don't mind. My throat's a bit dry. It's actually vodka. No, just kidding. Is that on film? So anyway, hi. How are you doing today? Who likes Docker? Uh-oh. Yeah, some people do, some people don't. Well, so the impetus for this talk is to fit what normally is a 3-day workshop or lots of different experiences in an hour, which should be fun. So the whole so many Docker platforms, so little time thing, the so little time thing is maybe not enough time for everybody to know all platforms, but also maybe only a little time to talk, so I might have to go a little bit fast. I have a lot of things I'd like to share with you. Maybe I should introduce myself. I don't know if I've met everybody, but Michele Bustamante. I'm a founder of Soliance, and we have an architecture consulting company that has, of late, I built a microservices practice with a lot of great people in the ecosystem, and so we've had the good luck of, I guess, getting some, real experiences on Amazon, on Azure, with DCOS, with EC2 container services, with Docker Data Center even, which is an interesting option, or at least will be probably at some point. So I'm going to talk just a little bit about those experiences, but also talk a little bit about just the things that we think about, and at the same time show a few demos, just sort of bring you through the story, if that makes sense. So I'm going to start with just sort of the flow of, we could be developers in a room and have a startup and just build images and run containers and put it on a box and have no load balancing, and that would be my simple Docker experience. But how many people do that, actually, and are not afraid to admit that? Right, because it's fast and it's effective, and the containers restart really fast. So if you want to replace one, and if high availability is not necessarily mission critical for that particular app, like maybe it's just your blog or website, and you just don't really need to pay for all that infrastructure, it works, right? So there's some people that actually go that route and just automate that with Ansible and so on. So that's one story. And then there's, of course, the complete other end, which is the one that we normally deal with when we think about people trying to move to microservices, right? So I want to take you through that flow, talk about Docker, networking composition, scheduling constraints, orchestration features, and as we do that, show some demos in the different platforms, and talk a little bit about how we make decisions. So it all starts with this, right? People get excited that they can build once and have it run on this machine and ship the same image somewhere else and have it actually run there and actually work, which is great. And that's sort of the promise in general of Docker, right, as we know it. So to start off, I'm just going to go ahead and jump into a command line here. Let's get into a good spot. Let's see which one I'm in. Okay, perfect. So I'm going to just tunnel into my build agent over here, and we're going to go into my directory. And what I have on here is 2 applications. I have an API service, and I have a web application, a client. So the application client will obviously call the service, and so we need to bring those 2 together, right? What I'm going to do first is just kind of bring this up here so you can see. And I'm going to jump into content-API. And we'll take a look at the Docker file. So this is just a simple node application, right? It's going to copy the directory over. There's no compile steps, so I don't have to do any sort of build of the application itself. And we'll copy the files over. We'll expose port 3001, and then start at the entry point. So that's it. Nothing fancy going on there. What I'm going to do first is do a Docker images. So I do have a couple of images on here, actually. So I'm going to go ahead and just do a Docker. Where am I? There we go. Oops, okay, sorry, got another thing to do here. I thought I cleaned that, so just a second. I'll show you my fancy remove all thing. Okay, because that's pretty fancy. Let's do this then. And we'll try and get rid of that image, perfect. And we'll do another one for web, perfect, and good to go. Okay, so Docker images. And it looks like we're just about good. OK, so I'm going to ignore the other two. They don't matter. So I have Argon already downloaded already, and so now I'm going to go ahead and do a build. So we'll do a build of the API. So I'm going to build the content API. I'm using a prefix dustblonde. That's my Docker Hub account. So the idea would be eventually I'm going to push that to a image registry, right? So on my machine, as a developer, this is something I work with some of my companies around in terms of getting started. We need an environment on our local. We need to be able to run and test things just as regular APIs. And then we need to flip the bit and be able to run it as a container, hopefully with environment variables just allowing us to switch between the two, right? So it's one of the sort of new procedures that happen. If you're in Visual Studio, you would do it one way. If you're using Sublime, you would do it another. But it's a thing to think about, right? So when I go ahead and build this, I should be able to... Oops, something else went wrong here. Oh, I'm not in the right directory. Excuse me for that. Content API. I think I moved out. And we'll try that again. Yeah? Build. OK. Oops. Apples. I'm completely, yeah, I messed up my command line and I hit something, didn't I? I missed the dot. Hello. I think something's happening while I'm typing that's mischievous. So anyway, that's going to go ahead and build, and that was only 5 minutes. Really, it shouldn't have taken that long at all. It would have been like 1 minute if everything went well. So okay, so I have an image now, right? Docker images, Docker images. Yeah, my typing is like a little latency here. I'm going to go slower. That's the problem. So Content API is now there on the top, right? So dustblonde Content API. Not sure if you're actually seeing the full word there. What's up with that? Yeah. Better? OK, so I have this running. If I do Docker PS, we're going to see that there shouldn't be any containers running right now. So what I'm going to do is also run that API. So we'll go ahead and do a run. I'm going to just do a quick run command. And a couple things I want to point out here. One is, when I run locally, I could just run the API by itself, but I also want to connect the web app to the API. And I also would like to do that with something simpler than a hard-coded API URL with a port. So what I'm going to do is use DNS. And so I'm going to create a network. So I have this network called Fab Medical that is already created. And so I'm attaching that when I run it. I'm going to show you how to do that with a compose. So the point of this is really just to show that one of the things I might consider is how I want to connect containers and package those. Because when I go to a real orchestration engine, I'm obviously going to have a way to stitch those up to a load balancer. I'm going to have a way to have requests to the load balancer find the right container and actually have multiple instances of that container with different ports randomly stitched and distributed across the nodes, right? So I want to still have that same configuration or potential behavior when I'm running locally so that I can have that consistent environment variable progression through my development, through my tests, through my orchestration engine, if that makes sense. So I'll go ahead and run this. And all that does is basically give me a running API. So if I do a Docker PS, we'll see that it's running. If I do a curl on the endpoint, I should be able to do a localhost 3001. Speakers is the endpoint, and that should give me a bunch of stuff, which it did, right? So we know it's working. Great. So I'm going to go back and do a content web. And the same thing goes here, but this time I want to do a Docker file and just show that I have an environment variable there, right? So right now, the environment variable is actually pointing at localhost 3001, which would mean that when I run this, I should be able to hit the outside port. The web container should be able to find, the web container should be able to find the API container, but there's a catch, right? If I'm coming in from outside, there needs to be some form of DNS, and that's where the network would come in. So if I'm actually hitting at localhost without a proper DNS, then that's actually not going to work. So I just want to illustrate that first so that you knew that there are some environment variables in there, and also that the app is actually respecting that internally. It's actually calling the API based on the environment variable. So I'm going to go ahead and exit. And let's go to Docker build. And we'll build the web this time. And yeah. Oops, forward one. Here, I'll just get that. And Yeah, that just did the wrong thing. We'll let it finish. Because, well, I have no choice, probably. There's that. Okay. So, let's see. Finish one of these days. Okay, let's see what I actually did. All I did is run that API one again, which is wrong because that will replace the API with the web content. So we're going to give that another shot. It's fun watching the command line run by, though, isn't it? Cool. Content API is probably a mess right now, so I'm just going to go ahead and fix that up. Yeah, build content API. And we will let that run, and I will now have another image. Okay. Docker PS, I still only have one container running. Docker images, I should have the new image, and I do. So I have the content web image, and now we can go ahead and try to run that. So let's go ahead and do a run, only this time I'm going to do it with web. So you'll notice that on the command line, I'm passing a content API URL. So I'm overriding the API URL with the DNS name of API, which is the name of the actual API when it's running. So basically, under Fab Medical, when I registered the API, I'm using the DNS name API, and I should be able to then hit that when I'm coming in from outside, because there will be a network to hit on this single Linux box in the cloud. Okay? So this is equivalent to passing parameters that would be like a service description, right, or a task definition. And so this is the very beginning of the things we think about when we're running containers. When we go to an orchestration engine, we need a way to supply those environment variables, network definitions, dependencies maybe between different containers in a single definition, which would be potentially done with a compose file, which I'll get to, or potentially be done with other capabilities that are provided by the platform. So for example, when I upload a container to Google Container Engine, it gives me a way to use a compose file or a YAML file. But when I go to Amazon Container Services, I have to, or EC2 Container Services, then I have to provide a different format, right? It's a task definition. So I convert the YAML to a task definition. When I go to DCOS, I'm using a JSON file. It's a completely different format. But they all sort of contain the same thing. And the beginning of that is, how do you want to run the container? So the point that I'm just bringing up here is right now I'm just passing a couple things on the command line, which happen to be to the run command, like I need to know the network, I need to know maybe some environment variables, and those are the things that would switch when I go between environments, right? And so eventually I would do that a different way. Right now this is pretty crude. It's just Docker, native, right? So when I run this, it will have that override. And if I do a Docker PS, then I have the two containers running. And if I do a curl against it, then I should be able to hit localhost. Oops, keep doing that. And 3000 for the web. And it should just return, that the page is up, right? Now, I'm not going to see success from the web page to the API unless I actually go ahead and run it and hit something that's going to call the API, right? So I'm going to head over to here. And this is the website. And so if I go to the main part of the website, if I just kind of launch the first page, let's do this. Then I'm not going to see anything interesting, but when I click on the speakers or on the sessions, that's when it's actually calling the API, which returns all that JSON you saw the first time. So we know that then that's working, and had I gone through the step of showing you without the network or misconfiguring the environment variable, then we wouldn't see that work. Make sense? Okay. All right. But that is a quick start. Now, the point of that was just to sort of talk a little bit about task definitions, talk a little bit about the fact that it actually applies even with Docker native run commands, and that there are many ways to do that or achieve that same goal when we get to the container platforms. Docker Compose, then, is the sort of Docker native mechanism or descriptor for creating service definitions, which would be a YAML file. And so in here, I can follow the definition language to put things like, how many, maybe multiple container images to maybe link them together or make them dependent on each other. There used to be a way to do direct linking, but that's sort of obsolete because we really want to use DNS. I can specify the network. It will create the network if it's not there, and then attach or join that container to the network. It will allow me to specify volumes, environment variables, and other configuration values that I might want to have access to, okay? So that definition file then becomes a thing that theoretically, if all platforms were created equal, they would all share the same language. They just don't, so it's a bit of a modification. But we can take a look at how I would run that from the same machine if I just wanted to. So let's go ahead and do a quick removal of all those containers. So Docker images or Docker PS should show me nothing running, right? And then what I can do instead is go back a level and do a Docker compose. Oops, sorry, I forgot the dash. Up T. And then that should address starting both of those. And then I should be able to then, see them running. So let's go ahead and do that, right? So now I have at 3001 and at 3000 those API and web application running, but it was done with the single command, so it sort of grouped them together, right? So it's a single definition for actually multiple containers. It doesn't have to be multiple containers. Could be one with environment variables and so on, right? So this would be a way for application grouping, for example, if you want them to be a single sort of deployment artifact. And not all of the orchestration engines let you do that the same way. So each of them might have their own thoughts around how do you combine. So when we think about composing and we think about application grouping, with Kubernetes you have pods, which allow you to have multiple containers treated as a single unit in terms of deployment, upgrades, and so on. When we think about DCOS, they have application concept, which I think they just renamed to services because there's been an update. So now I have to remember when we go in there. And then in AWS, it's a little bit less obvious, right? You have to upload a task definition, and it's not exactly done in the same way in terms of grouping. So we'll see AWS when I go in there too. Okay? So again, compose, grouping, network, environment variables, having it all run at once. It looks like I can still, curl the URL. And that should work. And I should be able to hit that, and that should work, and I should be able to still hit the site. And that should work. Okay, so far so good. That's good. So, because you just never know with these connections and things. Okay, so we've done a bit of a compose. We've done a couple of quick tour items. Let's move on for our quick hour. So the other thing we need to think about is where do I push the images, right? I'm going to be a developer developing locally like I just did. I can fully function that way. I can have a build agent I'm using in the cloud. I don't have to actually even work off my local, but I could. I could use Docker for Windows and work locally the same way. I'm working off a Mac here, but this actually does happen to be a Linux box in the cloud. Okay. When we look at actually deploying to another orchestration engine or to deploy to an environment in the cloud, I'm not likely to be tunneling in like I'm showing now and manually doing that deployment, right? So I need to be able to pull the images from somewhere, first of all, and then probably that's on purpose because of my AWS demo, but I'll turn it off for a sec. I might get an alert later. So remind me to turn it back on. So I need a place that I can put the images so that they can be distributed, so that the orchestration agent cluster can actually pull the images down and run the containers, right, as part of a scheduling act. So we have to pick a container registry for that. So in the demos, I'm using Docker Hub, right? So Docker Hub, you can do free, open, public containers and have your own account. Likely for a company, that's not going to suffice. You can have a paid account in Docker Hub to do the same. But likely if you're choosing a platform like AWS, then you're going to use the Amazon Container Registry, right? So you're going to use that instead. EC2 Container Registry. If you're working in Google container engine, then you're going to be using its internalized registry, which it provides for you as part of it. If you're using Azure Container Service, then you're now able, only of late, to use the Azure Container Registry. So up until then, I was kind of stuck in Azure, right? Like, what do I use? For demonstrations, I could use, the Docker Hub, but otherwise I'd have to have a paid account or go through the heavy burden of implementing my own registry and hosting that cluster and managing that cluster, which is yet one more thing to manage out of all the things I'm now taking on when I take on a microservices architecture and containers. Make sense? So we probably want something built in. We want to try not to have to deploy it. I've actually worked with teams, and we've managed to finally get one up and running, but it's just not really trivial, honestly. It's better to have a hosted option if you can, something baked. Then there's the new Docker Data Center implementation, which is a Docker native but paid enterprise product that sits on top of Docker and Docker Swarm and so on. And that comes also with a DTR, or a Docker Trusted Registry. So they try to take the pain away for you by giving you a product you can pay for that makes it easier to set that up on your own VM. So you're still managing it. It's still your cluster. So it's not a hosted service, but it's at least something accessible to you, maybe a little easier than manually trying to deploy it. Make sense? OK, so we need to care about registries. We're doing that because ultimately we want to probably at least do the CI part of CI/CD. Not everybody wants to automate all the way through to deployment because of the risks associated. You have to be very ready for that. You have to be ready to respond, to roll back. You have to be doing drills around those things so that you're able to manage all these hundreds of containers that are floating around. They probably don't float. That was just a badly chosen word. So the idea would be at least I want to be able to check in and have it automate building the image, at least. And this is an interesting topic, too, because what I need to care about in this whole world of containers and orchestration and deployment is the process for not only just building an image and having it deployed into the image registry, but how do I tag these things? How do I promote these things through environments? How do I get it from dev to test to QA to production? A lot of folks maybe just rebuild, right, from your source today when you're not doing container work. So you're probably just, expecting that a particular label on the source, if I build it once and build it twice and build it 3 times, it'll just be the same, right, except for environment variables. And that should be the case, but maybe there's just a slightly more reliable aspect to this process, which would be you literally built it once. You literally don't touch it again, and that same image literally went from dev to test to staging and to prod, with the only change being those environment variables that come out of your service description and so on. Make sense? So that's the idea, is we want to get to a point where we have no problem with automating the build of the image. Let that happen all the time when developers are checking in, but we need a labeling process for after the fact. The default labeling will be latest. The thing we need to think about are repository tags. If I'm pushing it to Azure, Amazon, DTR, Google Container Engine, Docker Hub. Actually, Docker Hub doesn't require anything but that you put your account in the name, which is why I chose DOSBlonde/something. But the others require some very long, interesting tags to get at that registry, and then you obviously have to have security around that. With Azure Registry, we have Azure AD, and it's actually surprisingly, because I'm not always a fan of the process of setting things up in Azure with AAD, but it actually works very, very easily in this case. It's streamlined, really nice. So I can set it up so that developers can each have their own account and do their own push of images to that Azure registry. That raises another question, though, right? Should developers ever be doing that? Maybe to a dev area for testing, right, between each other. But when it comes to the CI process, really legitimately, the stuff you check in should just be automatically built, right? There should be zero reason that you have to do anything but check in and an image appears over on the other side, which you can now pull by saying get latest, which is the default. And so that's a pattern that you start to establish. Again, I'm giving you, some discussion around this because it's a thing on that list of things that we have to think about now where we're moving into the orchestration flow. And it does take a bit of strategy, but not too much, right? So we got repository tags. We're going to have version info, maybe which service it is, some sort of labeling. And at some point, we might include the branch label or something. So if we move over to master and do a merge of updates that are going to go to production, and you have a process for that within your Git repository, then maybe Jenkins can pull that and intelligently apply the right tags. So we've done that before with Jenkins and had it set up, the right tagging mechanism based on some, branches, for example, in the repository. The other process would be, to have another entity do the retagging. For example, Rundeck would be another example that we've used in the past on our team to apply images with tags as they go through and traverse the environments. And so Rundeck's responsible for the actual orchestration and delivering of the scheduling instruction in that case. For example, with Amazon, you need that because you don't really have a full orchestrator in Amazon. Okay? So getting things into the registry is not too hard. Getting things out of the registry, again, not too hard if you know what tag you're pulling. Securing the registry would be obviously a process that should happen within your ecosystem, probably beyond this discussion. But, what I've done already in here, if I take a look at the images, right, I've got this content web and content API. And if I do something like, let's do a tag. And what I'm going to do is rename that to my DOS Blonde repo, just for illustration. And Content API latest is going to be renamed to, let's say, V2, because I've done an update now, right? So, oops, I know I spelt it wrong, thank you. I'm typing at my normal speed, but apparently that's too fast for this connection. I'm really that fast. Yeah, something to be impressed by. I'm sure everybody is really. Okay. So what I'm going to do is just quickly go over here to the browser. I'm going to make you dizzy for a sec and find it. And we've got our repo over here. Let's see. So DOS Blonde. I've got this content API, and it's already got a latest tag. So I just actually cleaned that up and recreated it. And what I'll do is do a Docker push. Oops, sorry. Read my mind, why don't you? Content API. And so that will do is, push any updates to the image layer and also retag, apply the tag also in the Git, Docker hub. I wanted to say Git repo. So we'll come up here and refresh. And I should have a V2, if I'm not mistaken. Well, then that wouldn't work, would it? No. Pair programming. I'll catch you later. Okay. So did I do it or not? Oh, I pushed the wrong one, and okay. Well, I meant to do that because I wanted to show you how easy it is to get mixed up, because you just really never know, honestly. It's important that we think about these things up front. Okay. All right, so let's see, Docker images. Web is V2 indeed, so we want to do a Docker push. DOS Blonde. Okay, try that again, Redux. It might even show in progress over here sometimes. Well, one of these moments it'll come through. In the meantime, the other thing I could show you is that you can create repositories that have automated builds. So if you're just testing and wanting to try that out, then this would be an easy thing to do. Just connect it to your Git repo and have your check-in, find the Docker file, build the image, and push it here. You can actually VSO with Visual Studio Online now has a really nice setup for that too. So we just finished setting that up in another project. It was kind of new feature going against the Azure registry and setting up the security with AAD, and it's working very nicely with VSO. So that's another, if you're doing .NET development with ASP.NET Core, most likely if you're doing Docker containers today, then that would be the thing. So that's a really nice setup, and you can do the full CI/CD, even have it push to your, orchestration environment, and have it schedule. So that would be an interesting way to look at it too, if you're ready for that in your production environment. What you might do is, for some environments, automate that, and for some environments, like say for production, maybe you want more control till you're sure about the whole CI/CD process all the way through. Okay, so I was trying to get back to my profile here, and I'm just not there. Let's try that. Okay, good. So I wanted to get to Das Blonde, the registry. Here we go, and web, right? And it should have finished. There we go. So, okay, so just a quick look at that. Let's keep going. Okay. So at that point, what I've done, I've built images, I've run them locally, I've got environment variables to flip between. I can run and play with my Docker images locally, and I can push them to a repo, and I can even go up to another server and pull them down. And if I'm just a startup, maybe I've finished what I really need to get to a certain point, right? Because I can stop and start and replace those containers without high availability, and it'll just be really super fast because it's fast, right? So I know some startups that do simple things like that, or even just simple projects that you have on the side that aren't mission critical. It's always really bad to say not mission critical because everyone thinks everything they do is mission critical. So, there's layers of mission critical, let's call it. But the fun begins now when we start thinking about all the other stuff we have to do, right? So what do I do in terms of, deploying to a cluster, right? And having multiple instances of that service running for high availability, distributing it across nodes, having it scale when it needs to scale, having it automatically stitch up to load balancer so that it can be discovered. What kind of discoverability are we going to be working with, right? Because there are layers of that too. So first thing we usually look at is the platform choices, right? Are you with an affinity to Amazon already, or Azure already, or Google already? Although I don't run into Google Container Engine very much. I know Kubernetes definitely has a lot of good wins behind its sales, but it seems like most large enterprise aren't looking at Google for their deployments in my world. That's my world. That's not everybody's world. So definitely Amazon, Azure. If you've got an affinity there, then you've already kind of chosen what kind of platform am I going to think about, right? With Amazon, you're going to use the EC2 container service. With Google, you're going to use Google Container Engine, and it's Kubernetes, basically, and then some. And it handles all of these things for you. It's built in. And then Azure Container Service is actually kind of different, right? What it does is it provisions, with a template, your IaaS environment for the orchestration cluster of your choice. So you choose if you want to use Docker Native Swarm, if you want to use DCOS, which is the Mesosphere stack with Marathon and Mesos, or if you want to use Kubernetes now, which is a new thing they just released, right? Support for. So I just spun up a cluster with that, but I haven't played with it yet in Azure specifically. But it's there, it's available. And then there's one sort of last choice I have on the list here. Again, there's others, right? Like this is just the mainstream that I run into. So, there's CoreOS, there's Rancher, there's all kinds of hosts that try to sort of, abstract you away from needing to manage your container clusters. But internal enterprises tend to go with the big names. So this is what I see more often, okay? Now, Docker Data Center is an offer by Docker. So that is their paid enterprise orchestration stack, which is really based on the Docker Swarm and then the Docker Trusted Registry. And it has this thing called the Universal Control Plane underneath that is, the orchestration engine. And so what Docker Data Center really is two kinds of offers. One is a hosted offer, and then the other is you deploy it on your IaaS, which I have done, actually. And again, it doesn't really have a lot of features, so more than anything, I run into DCOS with Azure, DCOS with Amazon. And then Kubernetes really just new with Azure, right? So that would be a good comparison with DCOS, I think, in terms of like capabilities. But if I'm in Amazon, I'm probably going to go with ECS because that is, built in. It's a bit more done for me. I'm still IaaS under the hood. I'm still managing VMs. I still have to provision VMs for my container cluster, but it handles the clustering part for me, right? So that gives me some services around that feel native to Amazon, and that works if you're in Amazon. Make sense? So we need to care about the management cluster, the agent nodes. We need to care about discovery of nodes, discovery of services that are hosted across the nodes. We need to care about the Docker registry, which I've already talked about, right, in terms of which one is where. I have a couple of charts at the end that will give you a cheat sheet, so I'm just kind of talking through it right now. The core features we care about, again, discovery, load balancing, routing, auto-scaling, self-healing, right? We want to know when something, if you tear down one of your containers, something's wrong with it, it's not responding, that it will be replaced, right? And a new one spun up. So things like that. And so that's where we get into the fun part. We can talk just briefly then first about scheduling. So scheduling and orchestration refers to the deployment, right, of your services and running them on the cluster. So running them on the agent nodes that are available. And so typically there will be a master node cluster that keeps track of all the other available nodes and their health, and all of the containers that are running and their health, hopefully, if the orchestration engine supports that. So if health endpoints are available, then it will track that for you. So when you, for example, on Swarm, go against the master node, the leader, and you don't know which one is the leader, you're just going against the load balancer, right, against the cluster, and you issue a Docker run with commands against the cluster, then it will issue to the available nodes for the number of instances that need to deploy of the container, instructions to go get the image and run the container, and with the right parameters and environment variables, right? So all that's done at the master node level, basically. So that's the idea, is that you ultimately want to send an instruction to the master to say, can you please run this container with these parameters? I need a minimum 2 healthy, maximum grow to 10. These are my environment variables. If there's any networking or dependencies on other containers, any restrictions like how much memory you need. And that's the thing that is kind of interesting to get used to, is the constraints concept. So let's take a look at that. So I have another VM here. Let me find my mouse. Okay. And okay, so I'm going to get out of there. Okay. So I'm going to connect to a Swarm cluster that I have in Azure right now. I deployed that with Azure Container Service, so it's just thinking right now and getting me in, hopefully. Okay. Let's go. Okay, so what I'm going to do is let's issue a command for just information, let's say. So what I've done is if you look at the bottom there, I'm hitting this, because I'm not coming in from outside, which would have meant I'd have to come in from outside with security enabled and so on. So instead of opening ports and enabling that, I'm actually tunneled in to, right now, one of the masters. And so I'm issuing the commands as if I'm coming in from outside, but I'm not. And the idea would be I'd have to hit a specific port, I'd have to issue the instruction, and this is what tells it to distribute that request so that it's going to issue the command against the master and apply it to the available agent node. So for example, if I say I want to have info, it will tell me the number of nodes I have available and healthy. So it's kind of giving me some insight into any containers that are deployed, how much CPU and memory I have available, and so on, right? And I have 3 nodes, so you can see I have different agents, right? So each of these agents start with, different value here. 79, and then 0000001, 002. So those are the ending, yeah? So I don't have anything running right now, so if I do the same docker ps command that I would normally do, it'll tell me I don't have anything running across the cluster right now. If I say I want to see what images I have, I might have one image that I already have down here, right? And so I have a hello world Docker, just a simple image, right? So what I'm going to do is run the container, right? And we'll run this, and let's see. So I'm going to do this and ask for a random port. So the -p just says go ahead and assign a dynamic port. The idea would be, ideally, that there would be a load balancer that it would stitch automatically the dynamic port that the container runs on, right? That's not going to happen here by default right now. I would need to do something more interesting with Swarm. But most of the other orchestration engines, that's built in. Like they have an internal load balancer. I'm going to show that in a minute too. So I'm going to run this now and just show what happens after the containers run. So if I do another look at Docker PS, it will show me that it's got a dynamic port of 32771, right? So that's the endpoint. It's mapping from the internal port 8080 of this particular container. And it gave a dynamic name. I don't really care about that in this particular demo. So what I was going to do next is show you what happens if I run info, and we kind of scroll up a bit. I should be able to see that one of the containers is now running on one of these nodes, right? So there you go. All right. Okay, so if I run this a couple of times, and actually let's just do that. Let me just get out and run the same one. It'll let me keep running them because the port's dynamic. But if I were to ask for a specific port, what would happen? I think 8080. Or something like that. It worked. It worked again. It worked 3 times, and now it can't, right? So that means it distributed one to each node, and it used up the port, but that's a resource that can't be shared, so now it can't distribute another, right? So that's a resource constraint, if you will. But I can have other types of resource constraints. So let's go ahead and do another info pass. And what we should be able to see here is I've got 3 containers here with not very much used on the CPU or memory, right? Because I haven't actually reserved any. I haven't said my container needs X to run. Most of the other environments actually require you to specify something for your container, because the whole concept is that you should get to know through drills ahead of time and load tests, like what kind of a capacity does the container need to operate in a healthy manner. And the idea would also be that if something doesn't work right, if it sort of exceeds memory, that container can fail or go down, but another one should come up in its place because you have these minimums set. I need 2 healthy, always running. So the orchestration engine should know enough to say, okay, I'm going to spin up another one. That's the idea. So right now, I'm just distributing freely, but I ran into a resource constraint for the ports. Let's try another thing. And what I'm going to do is delete everything on this in terms of the running containers. And so that means I should be able to see Docker PS, nothing running. And what I'm going to do is do a run, but this time I'm going to require 2 gig. So you can see that I'm asking for 2 gig over here. And so it will try to run one, and there's only 3 gig per box, right? And it will try to run another, and it will try to run another, and then at some point, no resources again, right? So that's, again, part of the whole idea is that I should be able to, constrain resources and dynamically assign, to each, not dynamically, but specify for each container what is the resources I require so that the scheduler can do its job, which is find the right node to put it on. There's other kinds of constraints like proximity constraints and things like that, but hopefully that just gives an idea of one of the considerations, right, of the container orchestration engine that we need to care about. So, this is just a screenshot of what we showed before, which is the containers, how many are there and how much is used in terms of CPUs and memory. There are other constraints we've talked about just briefly. And then here showing that I've already reached my, my constraint, right? I've filled with 2 gig or 3 gig. 3 gig is used of the 3.5, so I can't issue another command for a 3 gig, right? So, okay. And so I would get an error like that. I already talked about the fact that this whole process of then scheduling, which I just showed from a high level just with Swarm, which is simplistic and command line, right? I'm obviously not really going to do my scheduling that way. I'm going to have some automation around it. I'm going to have automation around deploying a container, and I'm going to have task definition or a service definition or an application definition, all the same, right? That describes what are the requirements of this container, of this service. What memory requirements, what affinity to other containers, so then the scheduler can do its job. So what I just showed you was the lightweight version of that is masked a little bit when you go into a platform. So the challenges we face are things like load balancing, service registration discovery, and server density. When we think about, I want to get as many containers running as are needed to serve requests, and if we start to, exceed load on those container instances, then I want to be able to scale them out. So I need to be able to set up some sort of alerts or alarms around that. That would be one example that the orchestration engine can provide for me, is auto-scale, right, of the container. Then the next step is when I start to run out of some resources on the actual node or VM, I want to auto-scale, the actual nodes in Amazon, in Azure, and so on. And so we get varied results with that depending on the platform we're using, right? So Amazon's got some ways to do it. Azure has, auto-scale capabilities, but it's not quite tied into DCOS yet, so that's all still coming together. But the point is, these are things we're thinking about, right? So that's another topic. And so what I could do is, just to take a look at EC2 container services for a second, one deployment that I might have is something around having Azure Load Balancer. So when we think about discovery, one aspect to discovery is having services deploy and stitch themselves up to whatever the load balancer is that is going to know how to route to that service, right? So I could either have an ELB attached to each service, or I can have ALB, which is now more intelligent, which will allow me to have dynamic port assignments, which will allow me to, just spin up additional services on an individual node instead of one per node. So in the past, we were stuck with one service per node because of port restrictions, because you couldn't get the dynamic aspect. And again, ALB shipped last September or something, so that was when we could start playing with that. And now we could build a better starting point around discovery. So one of the parts again around discovery is just let me distribute more instances with dynamic ports and have the load balancer somehow know about them. This is not dynamic discovery though, right? There's client side and server side dynamic discovery as well. For example, the client could call in and ask a console, for example, or Zookeeper or etcd, for information about where services are deployed in order to find the URL that it should call. So there's overhead to that. It's chatty, right? There's another request in the mix in order to find out which service should I call. But you're pushing it to the client in that case. I don't prefer that model, but there are probably isolated cases where that's useful. On the other hand, what you could do is set up, a cluster, say with console or something, and have that be what is communicated with, say, from either an Nginx tier or from even something you call from ALB that goes and finds out which service should I forward this to. But you have to set something up that can go and request where should I send the call if you want full dynamic discovery. So there's overhead to that. It's another cluster to manage. It's oftentimes not the first thing on the list for people if they can find another way to achieve something acceptable. And what's acceptable is typically starting with this, with ALB. So it's just a big undertaking to go down the road of console, for example, for dynamic discovery. So when we think about requests coming in through the public load balancer, those might go, for example, to EC2 nodes, and then I would have another private ALB behind another subnet so that it's not available to the public, and that would be maybe where the websites on the EC2 nodes call my services tier. So one of the things you can look at with container orchestration and deployments is whether or not you want to have a services tier that's on the orchestration platform, and have your websites just be traditional, and have your backends continue to be traditional as a migration plan, right? So I've got these legacy databases. I don't have everything isolated into domain boundaries yet. I need to take time to get that done. But we can start by scaling the middle tier and making that a more agile, deployment and development story. So I can, enhance features, create new product listings, create new services for the business that live in the middle and consume the same data models we already have. And then over time, migrate to that pure sort of microservice isolation of those data stores. And maybe even move the websites into the containerization story so that I can optimize my deployment and not have to have EC2 nodes as well, right? Both of those are acceptable models. It's just a process. It's a decision that you make, right? So having this dynamic, have services, I was kind of pointing on the wrong side here before, dynamically stitch up to the ALB would handle the sort of discovery of services that are healthy. You have to have health endpoints that are available so that ALB knows when to remove something from the ALB when a service is not responding correctly. That means your service, when you build them, have to right up front think about what is healthy. Is it just a 200 at a ping? Or should I be checking that a few other things are available? Or should I have two different health checks, one for sort of the ongoing ping, and then every once in a while, let's do a sanity check that the database is actually available on the other side. So you can think about those things, and those can be built into some of the rules around health checks and how ALB responds, for example, right? Okay, so one of the things I wanted to do here is go to Amazon, and right now I have some alerts set up. I'm going to turn my phone back on, and those alerts are I'm going to go through them in a second, but first I'm going to go and start a load test so that it can kick off, because it takes a few minutes. Okay. So let's do this. I think I'm in the right one. Okay, so exit out. I'm typing way too fast for this guy. Seriously. Okay. Okay, so I'll just show you what I'm doing here. Oops. Yeah. So all I'm doing is running a command that's going to send 1 million requests for over to the services that are running in Amazon right now, and it's actually putting in some instructions for how many calls to make and how many in parallel, right? 125 in parallel. And the idea is I'm going to load up those services that are just deployed right now so that we will get, we'll trigger some alerts. We're going to first trigger an alert of memory usage on the individual nodes that will trigger deploying additional services and distributing those. And then we're going to have a CPU overload that's going to actually increase the number of instances. So let me just run this first. And there we go. Okay, so that's going to take some time, and while we're doing that, I'm going to head over to the display. And so these alerts, this one will, like I said, right now this is red because it's saying if you're using less than 25% of CPU, scale down. But scale down means go down to 1, and I'm requiring 2 minimum, so it can't scale down. So it just shows as red. And again, I might not do that in production, but it's just a way to show that when this triggers a green, then we know the first alert has happened, right? Because what will happen is I will, start using more CPU, so that will first turn off that alert. And then I'm going to hit the CPU utilization for greater than 75. And what that will do is start triggering deploying additional instances to the Amazon cluster. So in my ECS cluster, I have 2 services and 3 tasks running. Here's the task definitions that I have available, and I think the one I'm caring about right now is, I think, no, that's not it. Demo task. It's this one, API. Okay. Sorry, I'm just like trying to figure out which one I last activated, because I had it all sitting there and then I went away. So. Yeah. That looks better. Okay, and the other thing I was going to do is go over here. I'm just waiting for this to kick off so that we can kind of get a look. What I was going to do is show you what happens. So basically, this is saying add 200% capacity. So it's going to go and try and add double the number of containers that I have right now, basically, that are running. So this alarm will change, and then it will follow with the rule. If we take a look at the one for memory greater than, it's going to talk about instances. So just a second. No. I'll go in here. Navigation is not clicking the way I like, so. Right. So CPU is first, and then memory is second. Okay, and so what you're going to see is when the alarm triggers, it will obviously show us some history, so you can see that maybe some of the things that have already happened. But basically, once the alarm happens, so this is my alarm, thank you. It sends me a text message, and so if I actually head back to the dashboard, we'll be able to see that it's probably got a refresh, but it's almost there, hopefully. Yeah, so now the one that's triggered is the CPU greater than 75, right? So this load is still going. It's still pushing out, requests, right, to the containers. And so based on that, because this one is currently triggered, it's going to start adding capacity to the cluster. So if I go back over to my container, let's come back to the clusters. And I think we'll just go in and take a look actually at the number. So right now it says desire task 2 and running tasks. So it might have already started doing it. Let me go to the tasks, and we can see they're running. Let's see if it's added any yet. It's probably going to be adding some more. It takes a little bit of time, so unfortunately I'm just sort of waiting now. So let's see. The other thing I can do is I can really cause chaos, and I can delete a couple of APIs. So if I stop these, it'll also continue to try to provision enough, and it will do that automatically, right? So these are set up to have a minimum number of healthy, and that minimum healthy includes 2 right now. And so that's what the task definition indicates. And so this will automatically start spinning up additional. While we're in here, because of course I want to just give you a quick taste also of the DCOS, let me come into DCOS. So in DCOS, while Amazon is figuring out its scale out and the alarms are going on, right now I have, let's go over here. There's my other alarm. Okay, it's going to add instances now. Let's go to my terminal, which is this one. It won't jump until I get there. Okay, I need to tunnel in so that I can see my DCOS panel. So this will stop being like 0. So the other thing I wanted to illustrate was that when you come into DCOS, it's a totally different view of similar things, right? You're going to know how many nodes, you're going to see how many tasks are running. But more importantly, if I come in here, I have a public Marathon load balancer. And I also actually have that listed here probably, right? And then I have an internal load balancer. So the internal load balancer is responsible for the API. And if I look at the logs, you'll see that when I actually add a new API, it will dynamically configure it at the front end of the load balancer at 10,001. So it's going to stitch up dynamic ports as I add and scale. So I'm going to just go over here and actually show you the services that are running. I have an API, I have a website, and I have my internal load balancer attached to the API. So if I select API and I do a scale event and I add, say, 3 nodes, so I'll go to 5, it's going to start adding those, run them, stitch them up, distribute them to random, nodes. It'll show that they're healthy at the moment. And then if I go over to my tasks here, I got a bunch of events here, so it just added several new services basically to the internal load balancer so that it will dynamically find those basically when requests come in. So I guess a couple things just to sort of tie it together, because obviously we have to finish up soon. You can see right now that my cloud watch is actually all healthy, because what it's done is it's finished its scale activity, right? It's added instances and it actually added nodes. So it'll start scaling down if I actually kill this guy over here, and then that will start to go away and I'll get alerts in the other direction when it's done. So for example, here, I can go to here and kill it, and that'll start kind of cleaning up. But let's kind of just sum up what I've got here. So one of the things we talked about was self-healing, and I showed that just really fast for time, which is I killed one of the containers. Another example would be the container's not healthy anymore, and a new one tries to spin up. It can only do that if there's enough resources to do so, so you always need a little spare in order to have the ability to spin up the new before tearing down the old. That counts for upgrades, rolling upgrades, so that you never have any downtime, always high availability, always 2 nodes healthy. The 2 new ones come up, the 2 others are drained, and that's what the orchestration engine will do. Amazon will handle that for you automatically. DCOS handles that for you automatically. Kubernetes handles that for you automatically. So those are, nice features of all 3, really. I don't think there's really a question that all 3 can't do pretty much all the things we care about that we've talked about. So when we look at the summary, basically each of them has their own native registry, whether or not you can use them on-prem or cloud. So one of the things that I find I run into on-premise is the decision around, should I use a cloud native mixed with an on-prem, deployed item? And what I've kind of landed on is I think you want to go with something like DCOS or Kubernetes, both in the cloud and on-prem, for hybrids, when you need to have, because you want to learn to manage one thing. It's too much to learn 2, in my opinion. So that's a decision that's cultural as well. But if you're in Amazon or Google or Azure, these are your choices. And I kind of already went through that, so I just put a chart up here just to follow. So in summary, in only an hour, we talked about simplicity of containers, developer workflows that you have to care about. You have the service definitions. You have the immutability of the images, tagging them all the way through to production. You need the platforms to handle all the rest of the health concerns. So we need scheduling, constraints. We have to think about the constraints. We have to do drills before we go live. It's a lot of work, right? So you have to see the light at the other side in order to want to do it. But if you do it right, we're forced to do it right, or you won't be successful, essentially. You can scale the containers. You need to know how to auto-scale the nodes as well. You need to think about the load balancing and discovery aspects. So I just showed really load balancing, not and dynamic discovery underneath the load balancer, but not console, which would be the full dynamic discovery methodology. Health checks and self-healing, so killing a node, having it regroup. And then, just a peek at some of these, So I think in terms of your decisions, it really comes down to which cloud are you in, what do you have an affinity to? It's cultural a little bit. Most of these actually deal with all the features. The only ones I would say maybe aren't as fully functional yet, but it's going to be interesting in the next year, I think, and that is Swarm, Docker Native, and Docker Data Center, because those are coming up fast. Whereas Kubernetes is already pretty seasoned, and DCOS with Mesosphere and Marathon are also very seasoned, right? And of course, Amazon is quite seasoned. I think also it's going to get interesting in Azure, because Azure is just a template right now, but it's going to start providing services around all of that, which is going to be really helping you to, manage the cluster or aspects of it that are part of your Azure assets, right? And so I think that's sort of the difference between, is it really IaaS or is it more? It's going to be more. Right now it's a bit more like IaaS, right? And remember the goal of this, which is deploying a bunch of little things instead of big things and having a lot to manage, which means you have to do it right the first time. You're going to start with 2. You're going to get to 10 services, and then finally be able to go up to 100 or 200 because you've mastered that whole cycle that we talked about a little bit, and then some. So, business can have new features everywhere, and that helps them to, get what they want, because you can just replace and have those rolling upgrades and have it be seamless because you've done the drills and you've done the right things to master the orchestration platform. Because microservices, and it's about the business. So I guess, in summary, forget everything you did before and enjoy, looking at whichever platforms make sense for you. And if you ever have questions, feel free to send them, because our team's been working on a lot of them, so it'd be interesting to find out what kinds of questions people have in terms of digging in and getting started. So happy to try to help if you need it. All right, take care. Thank you.